All right, so here's a good problem for you to test you to see where you're at. It's a little bit of a review problem, but let's see how you do. Okay, why don't you guys practice it at home, see where we're at. If you can't remember how to do this one, then watch us go through it, but give it your best shot. All right, what do we do, Fred?
We write an equal sign.
Very good, an equal sign. What goes to the right of our equal sign?
Grams of sodium carbonate.
Very good, Na2CO3, right, our sodium carbonate. That's what we want. So now, what do we do?
Well, I would start with moles of HCl on top to convert that to moles of sodium carbonate. But we need an equation too.
That's right. We need an equation. Should we start with the equation first?
Yeah.
So, what are our chemicals that are reacting?
HCl and sodium carbonate.
Very good. HCl and sodium carbonate. And what are the products?
NaCl and HCO3.
Is that what you said?
Yeah.
Okay, there's one thing that's wrong with that.
Oh, H2CO3.
Very good. Very important to pay close attention. How did you know it was 2?
Because hydrogen is a +1 and the carbonate is a -2 charge.
Very good. Okay, so now balancing the equation. I should have let you do that, but can you see that?
Yeah, I see that. We did this one before.
Yeah, we did, didn't we? So, now I can relate my moles of HCl to moles of sodium carbonate. It's a 2-to-1 ratio, right? Now, where did they give us moles of HCl to start with?
3.11 molar is moles of HCl per liter of solution.
So should we start that here?
Yeah.
3.11 moles of HCl for every 1 liter of solution. Very good. So now I can go from moles of HCl to where?
Moles of sodium carbonate.
Very good. And what was the ratio?
1 on top, 2 on the bottom.
Very good. This is the stoichiometry there, right?
Yeah. So now you're in moles of sodium carbonate. You can go to grams of sodium carbonate.
Very good. Grams of sodium carbonate. And now, and that's what I want, praise the day. You know how many on each?
Oh, it says 106.
Yeah, 106. That's what the 105.9 is, right? Grams for every mole. So, what do I got to do?
I think you're done.
Well, I'm not quite done, am I?
Oh, no, because you got solution down there.
Very good. I got liters of solution. So now I have to get rid of that, and that's liters of the HCl solution.
Well, they say it took 25 mils, or 0.025 liters.
0.025 liters of my HCl solution. Very good. We got it right there. So our answer is going to be 3.11 divided by 2 times 106 times 0.025. Okay, very good. In some problems, it becomes very important to know the concentration of not just the chemical, but the ions. And we've worked on this before, but we kind of want to make sure we recognize that if I have a solution of 0.6 molar barium chloride, that's not necessarily the concentration of the chloride ion, for example, or the total concentration of ions, right? 0.6 molar barium chloride, you put barium chloride into water, you no longer have any barium chloride.
What do you mean?
Well, you know, when you put an ionic compound into water, it separates into its ions. So instead of having barium chloride, you have barium ions and chloride ions.
Oh, yeah, you told me that before.
Yeah. So if I have 0.6 molar barium chloride placed into solution, what I end up having is 1.2 molar chloride ions. Because for every mole of barium chloride, there's 2 moles of chloride ion. You see that?
Yeah, I see that. And you would have 1.8 moles of just ions altogether.
1.8? What do you mean?
Because there's 3 moles of ions for every mole of that material.
Okay. So if the equal sign had said, to the right of the equal sign, they wanted to know how many moles, or how many moles per liter of ions, right? Then we could say, well, I have 0.6 moles of barium chloride, and for every mole of barium chloride, what?
3 moles of ions.
That's right, 3 moles of ions, because there's the barium ion and there's 2 of the chloride ions. Okay, very good. That would be 1.8 moles of ions for every liter of solution. All right, so moles of ions can differ from moles of material, and in this question here, we need to know moles of ions to be able to answer the question. What volume of a solution containing 0.5 molar silver ion will be required to react with 100 milliliters of 0.075 molar chloride ion? So try this at home. After you're done, what volume of solution?
So, equal sign milliliters of the AgL solution.
Very good.
And then I think I need an equation.
Yeah, it'd be nice to have an equation. Have any ideas?
Well, all we have here is the silver ion and the chloride ion. They don't tell us how we got the silver ion or the chloride ion. No, what do you call them?
Counter ions?
Yeah,
Yeah, can you do it without counter ions? Can you just use the net ionic equation?
I guess. So silver and chloride would come together in a 1-to-1 ratio.
Very good. So I can just write this, AgCl. There we go. So silver ions coming together with chlorides in a 1-to-1 ratio makes our silver chloride. So that's a chemical reaction. That's all we need to know, and that's all we were given in terms of amounts of material, amounts of the different reactants in our net ionic equation. Okay, so with that equation, we can get to milliliters of silver ion from moles of chloride ion, right?
Oh, okay.
So we have 0.0075 moles of chloride ion, all right, for every 1 liter. That's what the molarity means, right? The big M. And this is liter of the chloride ion solution, Cl ion solution. Okay, so now I can go from moles of chloride ion to what?
Moles of silver ion?
That's right, moles of silver ion. And then I can go from moles of silver ion to what?
You can use your molarity to go to liters of silver ion.
Very good. I'll go to liters of silver ion. I was going to go right to milliliters of silver ion, but that might be confusing. Liters of silver ion going to milliliters of silver ion. So there's 1,000 milliliters for every 1 liter. Now, where do we get this information?
That's just the molarity upside down. So it's 0.5 moles of silver ion for every liter of the silver ion.
Very good. Now, what's this ratio?
That's 1-to-1. That's the equation.
Stoichiometry there. Excellent. So I went from moles of chloride ion, moles of silver ion, and then moles of silver ion to liters of silver ion, and then liters to milliliters. But I'm not quite done.
No, you got chloride solution down at the bottom left. But you can get rid of those liters by multiplying by 0.1.
Okay, so what you're saying is I can go 0.1 liters of the chloride ion solution because it says I used 100 milliliters of it.
Yeah.
Okay, very good. So I got rid of my chloride ion solution by multiplying by 0.1. So 0.0075 divided by 0.5 times 1,000, and that's, times 0.1, and then that should give me my milliliters of my chloride ion. Okay, very good.